So the next thing we can do now, the syllabus really only gives you infrared spectroscopy and mass spectroscopy. There's a whole range of different tests that you do to work out what a compound is. Probably these two alone are not enough. It would be nice to do a whole heap of other things that are listed in this paragraph. A bit of lip service is given to X-ray crystallography at the end. So moving on to mass spectroscopy first. So what happens is we grab the chemical and we hit it with an electron beam, and that takes an electron off and creates the molecule with a positive charge. It also breaks up the molecule and gives it the broken up molecule positive charge also. So the smaller fragments move down here and the heavier fragments move up here. And so what you're going to see here is a pattern like this. And so the molecule itself is here, and then this particular is benzene chloride, so the molecule looks like this, but it has a positive charge here. And then you'll have fragments, so it'll break up as well. So this is probably the benzene part, and that has just broken off with a positive charge. All right, now you're also going to get slight artifacts here. So because a small percentage of carbon is carbon-13, there'll be this little bit here, and quite a large proportion of chlorine, a third of it is 37, isotope 37. So you'll get a peak that's about a third the size of this one, exactly 2 points up from there. So that artifact is caused from isotopes.
So just be aware, as well as chlorine, you don't have to worry about iodine and fluorine because they have a small amount of any other isotope. So they're just written as 100%. There could be 0.01, I'd have to check, but you wouldn't worry about those two. The only one besides chlorine is you need to worry about bromine. So bromine's about 50-50, 79-81. So for those two isotopes, I would write them in your exam revision sheet. I call it a cheat sheet, but it's just a memorization sheet that you can store in your brain. And so this is quite nasty because look, if there's two of them, it's even worse. You get these this pattern here because they're broken up in different combinations as the two, or they're broken up separately. So quite a nasty trick to be aware of for the halogens.
So here's an example of ethanol. It doesn't have the artifacts in there. It's just got the peaks here and not the bits in between that are created. This is also a data booklet where you don't have to count them up. So for your ATAR, you're going to have to do this yourself. You're going to have to work out what the fragments are and add them up. And so you can see here that these are just fragments here. They're still molecules, but one electron's been knocked off, and so it's got a positive charge, and so it's been pushed down the mass spectrometer, and it forms this curve here, this graph. So let's go to a practice question then. So what you have is a molecular formula is C3H6O2, and so C3. What I basically do is draw a possibility and see how many different possible molecules I could get. Then I break them up into pieces, add them up, see which peaks they could possibly be. So 3 carbons, 1, 2, 3, 4, 5, 6 hydrogens, 2 oxygens. So put a double bond in there. And so the oxygen could be this one here. So I'll push the hydrogen over there. So it could be that. So this could be anywhere along here as well. And it could also be other things. So let's just see if double alcohol would work. So 6, there's the 2 oxygens, and how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. So it couldn't be that. So let's just go with this first and see if we get lucky. And if it's not, we'll try drawing other compounds and see if they work. So it's going to split here and here. If you split this particle off here, that's 12 plus 5. So that's, 24. 12 plus 12 is 24. 24 plus 5 is 29. What do we have here? We have something here at 29, so that's a possibility. Just this bit here, that will be 12 plus 3, so that's 15. We've got a 15 here. Not looking too confident at the moment. Let's look at the overall molecule, of course. And so that should end up as 74. So 3 carbons are 36, plus 2 oxygens is 32, plus 6 hydrogens is 6. And so that gives us a 4 there, plus 1, 74. So that makes sense, although we don't exactly know. So the graph does make sense, but we still don't know what that is. Although that is the question. What's this one here? So we can write that in, C3H6O2 plus. That 45, so let's see what this bit adds up to. And so that's 12 plus 32 plus 1, and that adds up to 45. So that's looking pretty good for the answer. So CO, we think that's a carboxylic acid group. So that looks to be C2H5 plus. So let's see how we went. So we got this one here right. Just check that and C25. Yes, so we got those 3 right. As you can see, we're getting clues, but we're not that confident yet. We don't have enough information really to be sure of that. And we didn't double check it with other possible compounds either. So if you get time, go back and check these answers with other possible answers.